What if I told you that Kubernetes, the thing everyone seems to be raving about, might be overkill for many of the apps using it right now? Yeah, it's true. We've all heard how Kubernetes is the ultimate tool for managing microservices, scaling applications, and orchestrating containers at massive scale. But what if your app doesn't actually need all that? You know how it goes. Someone says Kubernetes is the future, and before you know it, stakeholders and engineers alike are hyped up, throwing Kubernetes at every problem like it's the only tool in the shed. Even if your app just prints PDFs, suddenly it's like, quick, spin up a Kubernetes cluster. We all love shiny new tech, even if we're using a chainsaw to slice a loaf of bread. An overlooked alternative is serverless platforms like AWS Lambda and Azure Functions. No infrastructure, no clusters, no nodes to manage, just code that runs when you need it to. So why are so many developers and businesses still using Kubernetes when serverless might actually be a better fit? In today's video, we're diving into Kubernetes and serverless architectures, and I'll show you why for some apps, Kubernetes is over-engineering the problem. Whether you're a developer, DevOps engineer, or just choosing a tech stack for your next project, we'll break down how Kubernetes and serverless help you focus on writing code, but in very different ways. We'll cover when Kubernetes is the right tool and when it's time to go serverless. Before we dive into when to use Kubernetes or serverless, let's quickly cover what they are and why they're so popular. First up, Kubernetes. Sure, the dictionary definition sounds great. It's an open source platform for managing containerized applications, excelling at orchestrating containers, handling deployment, scaling, and networking across clusters of machines. But in practice, well, let's just say it's a bit more hands-on. That's partially why DevOps salaries are so good, in my opinion. Once you've configured Kubernetes, it will theoretically take over deploying and keeping your app running smoothly, even when things break or error or a deployment needs to roll back. It definitely excels when you have a complex architecture with dozens or hundreds of services that need to interact with each other in some way. It also gives you fine-grained control over networking, storage, and scaling, which would be useful for these large distributed systems. On the other hand, though, there's serverless. And just to be clear, the concept of serverless doesn't mean there's no servers. It just means that you don't have to manage them. Platforms like AWS Lambda, Google Cloud Functions, and Azure Functions handle all the infrastructure for you. You just write the code either as functions or even packaged as a container and deploy it. The CSP takes care of the rest, automatically scaling based on the number of incoming requests or event triggers or database changes or even message queue activity. Plus, you only pay for the compute time when your code is actually running. Serverless is really good in situations when you have event-driven workloads like APIs or background processing jobs or workloads that don't need to run 24/7. Clearly, it's simple, efficient, and easy to maintain. So while both Kubernetes and serverless can, in theory, help developers focus on code instead of the infrastructure, they go about this in very different ways. Kubernetes gives you control over how your application runs at scale, while serverless takes control completely out of your hands, letting you focus almost entirely on writing lightweight, stateless functions. And this leads into what I want to talk about in the next section, the developer experience. All right, so let's talk about one of the most important aspects of any technology stack, the developer experience. At the end of the day, devs just want to write code to fix bugs and add features, right? Whether you're using Kubernetes or serverless, the goal is to keep the infrastructure out of the way as much as possible and let developers focus on building the application or fixing bug from the previous builds, right? So how does that work for each of these platforms? On the surface, Kubernetes can introduce a lot of complexity, especially for developers who are more often than you would expect unfamiliar with Kubernetes and who just want to deploy their app and not worry about YAML files or scaling pods. And here's the thing, in many organizations, especially big FANG organizations, there's a platform team or DevOps engineers who build the tooling and workflows that abstract away a lot of this complexity from the developers. So with the right setup, devs can push their code and the pipeline, including Kubernetes, automatically handles deployment, scaling, and networking. Tools like Helm, Kustomize, Argo CD are important parts of the pipeline, which allows devs to focus on just a few key config files. But, and this is important, there is a learning curve. Even with abstraction, developers might still need to know some basics about Kubernetes, especially if something goes wrong. Things like debugging deployments, managing resources, or understanding pod behavior will leak into the development experience, especially in smaller teams where there might not be a dedicated ops team. Now, you could potentially argue that it's similar to the serverless experience, but with platforms like Lambda, the process is not that complicated. Developers write the code, package it, and deploy it. You define a few configurations like memory limits or timeouts, and that's pretty much it. Developers don't even need to think about scaling or availability. If a function gets called 1,000 times a second, Lambda just scales to meet that demand without any intervention. This is really great for smaller teams or even startups where minimizing operational overhead is essential essential. But regardless, what is actually better for developers? And that depends. With Kubernetes, you get more flexibility and control, but you also have to learn more about the system or have the support of a strong DevOps team. On the other hand, serverless gives you near zero infrastructure concerns at the cost of some flexibility. It's not so clear every time in reality though, so let's look into some specific use cases for both Kubernetes and serverless. Because spoiler alert, there is no one-size-fits-all situation in tech, ever. The right choice depends a lot on your application's needs and the team you have. First up, let's talk about when Kubernetes is the better choice. Kubernetes is fantastic when you're dealing with complex microservices architectures. If your application is made up of millions and millions, no, I'm just kidding, dozens or hundreds of services that need to communicate or be updated independently and also scale at different rates. Kubernetes gives you this control centrally. It's also great for stateful applications where you need persistent storage or databases running inside your cluster. For example, if you're building something like a large-scale e-commerce platform like Amazon.com, Kubernetes is definitely the way to go. It gives you the ability to manage traffic between services, perform rolling updates, and ensure high availability with fine-grained control. Also, let's not ignore the portability aspect. Kubernetes is vendor agnostic, so you can run your clusters on any CSP or even on-premise or hybrid or whatever. For a lot of companies, avoiding vendor lock-in is a priority, and Kubernetes allows you to deploy across multiple clouds. Serverless, on the other hand, works great when you're building event-driven applications or apps with sporadic traffic. If your app doesn't need to run 24/7 or you want to scale from 0 to hundreds or thousands of requests very quickly, serverless is the way to go. This could be things like API endpoints, scheduled tasks, or background jobs. Basically any workload where you don't want to worry about managing infrastructure or dealing with constant scaling decisions. Now, services like EKS do allow you to scale up and down, but the process isn't as fast or simple. EKS requires setting up things like auto-scaling groups and managing nodes, and scaling can sometimes take several minutes. In contrast, serverless platforms can scale almost instantly. That said, serverless isn't without its challenges. One of the biggest is the cold start issue. When a Lambda function hasn't been invoked for a while, it needs to spin up the environment for the first time it runs, leading to a brief delay. This can introduce latency, which might be a problem for apps that require instant response times. That said, there are ways to mitigate cold starts. For example, using message queues or event buffers, giving functions time to warm up without impacting the user experience. Cost is another big factor. If you have a small application with low traffic, running it on Kubernetes means you'll be paying for any idle resources you haven't set to scale down. With serverless, no traffic means no cost. But if your app is running constantly or has more predictable higher traffic, serverless costs can and will escalate very quickly and wipe out any potential savings. Of course, it's not always an either-or situation. Some companies do use a hybrid approach, combining the best of both worlds. For example, they might run their core services on Kubernetes, but use serverless for background tasks or certain parts of the app that are more bursty. Let's look at some real-world examples of companies choosing one or the other or both. First, let's look at a scenario where Kubernetes was the right choice. A great example of this is Airbnb. Most of you are familiar with them, but maybe you didn't know that they run a massive microservices-based architecture. Each service has different resource and scaling requirements, which is why Kubernetes works so well for them. It offers Airbnb the flexibility to deploy, scale, and manage the services independently. For example, one service handling user authentication might need to scale rapidly during login spikes, while another handling customer support queries might need fewer resources. Kubernetes makes it easy to define individual resource limits for each service and automatically scale them as demand changes. Airbnb also takes advantage of Kubernetes' ability to perform rolling updates. When they need to update a service, Kubernetes ensures the new versions are deployed without downtime by gradually replacing old containers with new ones. This way, their platform remains online even when they're pushing the updates to services in the background. Another critical feature is Kubernetes' self-healing capabilities. In a platform with millions of users across the globe, a service crash or failure is inevitable at some point. When this happens, Kubernetes automatically restarts the failed service without manual intervention, ensuring minimal disruption to users. This level of reliability is essential for a company like Airbnb, where services need to be up 24/7 for a global audience. Lastly, Kubernetes provides Airbnb with a really critical benefit: portability. Since Kubernetes is cloud agnostic, Airbnb runs their services across multiple cloud providers. This is important because on rare occasions, even the most reliable cloud service providers go down. I've experienced it firsthand twice when AWS suffered full-scale outages, and it's super annoying. And more recently, the July 19 CrowdStrike Microsoft outage earlier this year that impacted all those airlines really highlights the risk of relying on a single vendor. Now let's jump over to a serverless success story, iRobot, the company behind Roomba. They use, or did at one point, use AWS Lambda for their IoT backend, which processes data from their robots in real time. The reason serverless is so effective here is that the workload is event-driven. The robots send data periodically, not constantly. With Lambda, iRobot only pays for the compute time when the data is processed, and that makes it highly cost-effective. Serverless also works well for them because it automatically scales up when thousands of Roombas send data at or around the same time, and then it scales back down when the traffic slows. Another interesting use case for serverless actually comes from Coca-Cola. They use Azure Functions to handle their self-service vending machines. When someone makes a purchase, the function gets triggered, processes the transaction, and sends data back to their system. Again, the benefit here is that the vending machine traffic is sporadic, and they only need the backend to run when a purchase actually happens. With serverless, they avoid paying for all the idle compute time, which makes a huge difference at large scales. So as you kind of can see, the decision to use Kubernetes or serverless really comes down to the specific needs of the application. Companies with large, complex systems or constant traffic often need Kubernetes for the flexibility and control it offers, while on the other hand, companies with event-driven sporadic traffic workloads like iRobot or Coca-Cola benefit from the simplicity and cost efficiency of serverless. And I had mentioned it earlier, but what about a hybrid approach? One example of this I found is Ticketmaster, who uses Kubernetes for their core services but leverages AWS Lambda for certain event-driven tasks like processing upsells, sending push notifications, and handling data streams. For more persistent high-traffic services such as ticket sales, user authentication, and overall platform reliability, Ticketmaster uses Kubernetes and Amazon Elastic Container Service. While I haven't really touched on ECS in this video, it's another part of Ticketmaster's stack. It's basically a less complex orchestrator than Kubernetes, but it's also not cloud agnostic, which is a downside in my opinion. You can also sort of consider it serverless if you use ECS Fargate, but that's probably not relevant to the discussion. Regardless, this gives you the best of both worlds: Kubernetes for high traffic, essential services, and serverless for tasks that don't need to run all the time, but need to scale up very quickly when they do. So the question isn't whether Kubernetes or serverless is better, it's about picking the right tool for your specific needs. If your app demands complex orchestration, customization, and reliability at scale, Kubernetes is an amazing platform. But if you're building lighter, event-driven apps and want to focus purely on code, serverless is the way to go. And of course, hybrid is always an option: Kubernetes for critical services and serverless for tasks that need to scale up quickly and efficiently. Ultimately, the best choice is the one that saves you time, reduces complexity, and scales with your app's needs, not necessarily the most powerful tool like Kubernetes. And with that, I'd love to hear from you. What are you using in your projects? Is Kubernetes overkill for your app, or is serverless your go-to? Let me know in the comments below. If you found this video helpful, don't forget to like and subscribe for more tech discussions. Thanks for watching, and I'll see you guys in the next one. Bye.